Your AI agent just broke every security assumption you have. In 30 seconds, it authenticated to 5 different APIs, spawned 3 subagents, and accumulated database privileges no human would ever possess. Traditional identity says, person logs in, gets session, operates under role. But this agent? It's autonomous. It's ephemeral. And it's moving at machine speed through systems designed for humans typing passwords. Every assumption about who gets access and how they prove it just shattered. This isn't theoretical anymore. Non-human identities will hit 45 billion by end of 2026, 12 times the entire global workforce of 3.7 billion humans. Yet only 22% of teams treat AI agents as independent identity entities. Nearly half still rely on shared API keys for agent authentication. We're building a world of shadow agents, autonomous actors operating under opaque, overprivileged identities that security teams can't see, can't control, and can't audit. How does an autonomous agent prove who it is? Username and password require human interaction, completely wrong for automated actors. Enter certificate-based authentication. Each agent carries cryptographic proof of its identity. But here's the challenge: agents must authenticate to every resource they touch, databases, APIs, other agents, cloud services. Each hop requires cryptographic verification without any human ever touching a keyboard. No forms. No sessions. Just math. Authentication is only half the battle. Agents integrating multiple systems can chain API calls to achieve aggregate privileges no single human would possess. Traditional least privilege breaks when an agent accumulates permissions across dozens of systems. The solution? Just-in-time privilege granting. An agent holds permissions only for its current task. When the task completes, permissions automatically expire. 5-minute credentials versus 90-day API keys. Same access, dramatically smaller blast radius when compromised. Multi-agent systems compound everything. When Agent A delegates work to Agent B, how does B verify A's instructions are legitimate? What if A was compromised by prompt injection? What if the orchestrator itself is spoofed? Establishing cryptographic trust chains requires each agent to attest not just its own identity, but the legitimacy of the entire delegation path. If any link is compromised or overprivileged, the entire chain fails securely. No weak links. Traditional cloud service accounts provide persistent identity anchors: AWS IAM roles, GCP service accounts, Azure managed identities. But they still require embedding credentials somewhere in code or config files. Workload identity eliminates this entirely. Instead of storing secrets, the system attests to what code is running and where it's running. The infrastructure itself becomes the source of trust, dynamically issuing short-lived certificates. No secret ever touches the code. SPIF, the Secure Production Identity Framework for Everyone, provides the standard. Every workload, including AI agents, gets a SPIF verifiable identity document, a short-lived X.509 certificate or JWT bound to a unique URI like spiff/acme.corp/agent/summarizer v2. Spire implements this. A Spire server acts as certificate authority. Spire agents on each node perform cryptographic attestation before issuing identity documents. In multi-agent systems, SPIF IDs make the entire agent chain traceable and auditable. No shared secrets. No guesswork. OAuth's client credentials flow handles machine-to-machine authentication. An agent presents its client ID in secret, or better, a signed assertion, to get a scoped access token. OAuth 2.1 tightens these security defaults. But here's where it gets interesting. RFC 8693 token exchange allows an orchestrator agent to obtain a downscoped token on behalf of a subagent. The orchestrator says, I need database access, but only read permissions for this specific query. Privilege delegation preserves least privilege across the entire chain. Standard protocols weren't designed for agents. OpenID Connect for Agents OIDCA adds agent-specific claims, model version, capability scope, delegation chain. This lets systems make authorization decisions based not just on who authorized the agent, but what kind of agent it is. Similarly, Anthropic's Model Context Protocol mandates OAuth 2.1 for tool access. Before an agent can query a database or call an API, it must obtain explicit, scoped authorization. No unrestricted tool access. Ever. This represents a fundamental shift from long-lived credentials to continuously reattested, task-scoped identities. Instead of who you are and what you're allowed to do, it becomes what you're running, where you're running it, and what you need right now. The infrastructure itself provides the root of trust, dynamically issuing short-lived proofs that expire when tasks complete. This isn't just better security, it's the only way to govern autonomous actors operating at machine scale.